Yes, hello my dear friends, welcome to Yourpedia and ACP. So yes my dear friends, now as you know your GATE exam is over and I am getting lot of message that what not to do, sir. So you know, as GATE exam is over, you have lot of, especially if you have belongs to the mechanical engineer, so you have lot of opportunity in different PSUs like recently BEL, BHEL, BDL that are going to be conduct their separate exams. And you know one thing my dear friends, if you talk about GATE and all these exams, right, so there's a lot of differences my dear friends. In GATE, you know what is happening here, mostly numerical question is there, and that was, yes, obviously difficult question in the GATE going to be asked. But if you talk about different PSUs, a lot of PSUs in the queue that will going to be notify their notification. So here basic things is that they are that these all PSUs that are major going to focus on the conceptual part or basic part, basic things are going to be asked in GATE. And all these exams which will be conducted by the different PSUs is slightly different, or you can say in fact much more differences is there. GATE numerical focus is there, that is talk about the only basic concept is there. So that is the things. And yes, for the GATE, yes, it have also a lot of opportunity you will get from the GATE, obviously not even the PSUs, but you have a one chance to get the higher studies, right? So now I am going to start the one important topic. Even I was getting the lot of message from the student ki sir please take some topic of the heat transfer which is equally important for different PSUs which is coming recently like BEL, BDL, and very soon you will get the notification from the ISRO also, NGC also. So from that, even very soon you will get one of the notification from the FPCL, right? So for keeping all these things in our mind, now I am going to take one of the topic of the heat transfer which is equally important for any exams, not even the GATE. For all the exams it is important. Yes, in the GATE mostly numerical is there, but in other exam if you see only theoretical part is going to be checked, that are one liner question, we can solve it easily. So my dear friends, now today I am going to start one of the important topic of the heat transfer, and that one is what? Radiation. Now the first question is that why radiation is happening, what is the basic mechanism of the radiation, you know. So my dear friends, the basic mechanism, you know, from the very earlier from a very earlier class you might have aware that anything in the world is made by the combination of molecules, ions, or we can say the atoms, right? So what is happening basically, the if we talk about radiation, so it is basically going to be happen due to the electronic configuration change. What? Due to the change in electronic configuration, you know, whenever electrons at the higher state, it will try to move from another one orbit to another orbit. So whenever the basic cause of the radiation is what? Basic cause of the radiation is what? Electronic configuration, change in electronic configuration. Now students are getting confused, sir. From the second law of thermodynamics I know that heat can transfer from the high temperature to low temperature. Yes, but sir, radiation I am getting from the sun, and you know our temperature at the earth is more than that of the space. So sir, rays is coming from the sun, obviously from the space, it is crossing the space, then coming to the earth. And from the second law of thermodynamics I know heat can transfer from the high temperature to low temperature. So sir, in the space less temperature is less compared to that of earth. So how it is coming, sir? My dear friends, one important thing that you have to be keep in mind, radiation never depends upon the medium. It is totally independent from the medium. For the radiation heat transfer to take place, no need of any medium. If you talk about conduction, convection, there is need of medium. Like, but if you talk about radiation, no need of heat transfer. So if any times heat is going to transfer in the vacuum, only one mode is possible, that is what? That is what? Radiation. And second thing which is most important about the radiation, this is the fastest mode of heat transfer. What is the least mode of heat transfer? Conduction is the least mode of heat transfer. Convection is then between the conduction and radiation is the fastest mode of heat transfer. Even in the vacuum, heat transfer rate can be takes place up to the speed of the sound. Right, so that point we can see. And yes, my dear friends, one of the very famous people was there, name was Prevost. He told that everything in all around the world, everything having temperature more than 0 Kelvin, they will emit radiation always. So try to keep in mind the Prevost law. What is the Prevost law? All body above 0 temperature Kelvin emit radiation. Always, even I am going to emit the radiation, you are going to emit the radiation, that marker is going to emit the radiation, that board is going to emit the radiation. So every body having temperature more than 0 Kelvin, obviously all the body have, because 0 degree temperature can't possible. If it is possible, it will violate the second law of thermodynamics, right? So 0 0 Kelvin is not possible at all. So obviously body is existing, they must have some temperature. If they have temperature, they will always emit. That is the told by the Prevost. That law is known as what? Prevost law. Try to keep in mind. According to Prevost law, all body above absolute 0 temperature emits radiation. Okay. Now student is a little bit going to be find difficulty. So what is difference between the emission or the reflection? So I will come on that point, my dear friends. So that all the things you have to be keep in mind. Okay, heat transfer and yes, my dear friends, in this session I will take different types of question. So don't think only theory will be going to be covered, my dear friends. Here I will discuss all these questions we can see here. After completion of that topic, I will take different question. We can see all these different question once I will cover the topic. And then after that, what the possible question can be asked in your exam in BEL, BHEL, BDL, ISRO, whatever you can say. What expected question we can see after that. Once I will complete the theory, then I will discuss the different types of question which can be asked in that exam. Right, you can see all these questions I will discuss, and yes, their explanation is also there, so you can get that PDF by joining my free WhatsApp group right now. So at the end I will discuss all these questions. So before that, please focus on the conceptual part. Once it will be covered, then I will come on the numerical and question part. Not numerical, theoretical question is there. By keeping in mind, as I told you, BDL, BHEL, BEL, right, ISRO, HPCL, and various different exam is coming to be. So here you can see, well, visible na? Okay. Now come to the one more important thing, my dear friends. This is called is what? Electromagnetic spectrum. That question is also going to ask in the exam. Electromagnetic configuration, or you can say spectrum. You know, the rays coming from the sun in the different wavelength is there. Different is it visible, my dear friends? Is it visible? We can see different wavelengths: gamma rays, X rays, ultraviolet rays, visible rays, infrared rays, radar, radio ray, that all are coming. Now the question is that, sir, from the sun different range of the wavelength is coming, so each all are capable to produce the thermal effect? No, my dear friends, just try to keep in mind thermal effect that you are going to feel, only because of some part of ultraviolet radiation. There is entire visible and entire infrared, you can say the visible range. So what is the thermal radiation? The wavelength which falls under the 0.1 micrometer to 100 micrometer comes under the category of thermal radiation. Just 0.1 micrometer to 100 micrometer. In this, some part of ultraviolet rays will come, visible is totally coming, and totally infrared is coming. That is comes under the category of thermal radiation. Try to keep in mind that question is going to ask. Now the question is, what is light? So these are visible portion of electromagnetic wave which visible to the human eye, and the body which emit or visible range, this is basically called is what? Light source. Now I am going to discuss the some terminology which is going to be used in case of radiation. Now what is the terminology? Simple, my dear friend. Suppose that is one of the surface on which some incident radiation is coming. Obviously it will be reflected back, and this is incident radiation, right? Incident radiation, this is reflected. And you know, as I told you, every body having temperature more than 0 Kelvin, that will emit radiation always. So one emission is there, that is what? Here this is emitted rays. Emitted, everybody will emit. When I am emit, you are going to, everyone is going to emitting. So this is emitting, this is incident radiation, this is reflected, and that is what? Emitted. So first I will discuss the radiation flux, or we can say emissive power. What is emissive power? Rate at which radiation is emitted from surface per unit area of that surface is known as emissive power. So this is the any body. So whatever energy is emitted from the unit area or from per unit area, this basically energy known as what? Emissive power. So what is emissive power? Rate at which radiation emitted from a surface per unit area of that surface is known as what? Emissive power. What is irradiation? What do you mean by irradiation? So irradiation is basically rate at which radiation is incident upon a surface per unit area of that surface. Whatever rays are coming on that one, per unit area of that one, whatever rays is coming per unit area of that one, that is called is what, my dear friends? irradiation, and one term that I will discuss, radiosity. What is radiosity? So rate at which radiation leaves the surface per unit area of that surface. So you know, if you talk about leaves, so which one is leaves? This is the surface, so this is the incident radiation, or you can say the irradiation. This is reflected back, right? And you know what, you know, as I told you, there is a emission is also there, right? This is going to be emit. So what is the total energy which leaves the surface? So we can say the part of reflected rays, this is the part of reflected ray, G a part of reflected, and radiation, this coming is going to be, that radiation coming is going to be denoted by the G, and that is the that part of reflected, that part of incident radiation which is reflected, and that is, you can say, the emissive power of the body. So per unit area how much energy is going to be leave? So we can say, sir, E for emissive power and G of the reflection. So that will be called is what? Radiosity. So radiosity is the energy that leaves the surface per unit area of that surface is known as what? What you can say, the radiosity. Try to be keep in mind that is going to be denoted by the J. If incident radiation impacting on the body. Next coming, see here, that is one of the surface, right? This is the incident radiation, this is the reflected radiation, right? And here we can say some will transmit and some one will be the absorb. So that is the incident radiation G, right? That is the reflected, which is reflected back. This is something which is absorbed, and this is something which is transmitted. So if you making the energy balance, if you are going to make the energy balance, then what you can get, my dear friends? If you are going to do the energy balance, what we can get? Sir, in incident radiation is G. This is the some part which is reflected. This is the some part which is absorbed. This is the some part which is what, my dear friends? We can say transmitted. So what you can say here from that? You can say just take that one. So by this you, and try to remember that one, alpha plus low plus tau is equal to what, my dear friends? That will be equal to what? Simply we can say 1. So what will be reflectivity? That will be, what is the reflectivity? The part which is reflected back of the incident radiation which is reflected back, now known as reflectivity. What is absorptivity? The part which is absorbed is known as absorptivity. If we talk about transmittivity, so the part which is transmitted is known as what? Transmissivity, and try to be keep in mind all that. Now on the basis of tau, if tau is 0, that means nothing is going to be reflected, then nothing is going to be transmitted, then it is called opaque surface. Try to be keep in mind, if nothing is reflected, if nothing is transmitted, not reflected, if nothing is going to be transmitted, then it is called opaque surface. Tau is equal to 1, this is called perfectly transparent, or you can say dithermous. Try to be keep in mind. On the basis of rho, if you talk about, if rho is 0, then it is called a reflecting surface. If rho is 1, it is called perfect reflector. Now on the basis of alpha, if alpha is 0, called non-absorbing surface. If alpha is 1, this is called perfectly absorbing surface. That means whatever incident radiation is coming, totally is going to be absorbed by that. If alpha is 0, means nothing is going to be absorbed, then it will be called is what? Called non-absorbing surface, because nothing is going to be absorbed. One law which you will be very frequently going to use, known as what? Stefan-Boltzmann law. So what is the Stefan-Boltzmann law? This law given by the given the total emissive power of black body. First thing, try to be keep in mind, this is going to give the total emissive power of what body, my dear friends? Black body. And try to be keep in mind, black body emissive power is given by sigma T k power 4 watt per meter square. Try to be keep in mind, right? So emissive power of black body, that is basically, and one more thing, emissive power of black body is a function of what, my dear friends? Temperature. Emissive power of black body is a function of what? Temperature. You can say EB. EB is what? Emissive power of black body, right? B term I am going to use for the black. What is black body? I will discuss. Next term I am going to discuss here, emissivity. So what is emissivity, my dear friends? It measures how closely a surface can behave like a black body. Now question you can answer, what is black body? Yes, I will come on that. What is black body? So basically emissivity, that going to measure how a body close to the black body, measure how a closely surface approximate as a black body. What is emissivity? So this is the radiation emitted by any surface upon radiation emitted by black surface at the same temperature and emissivity, black body, in case of black body it will be equal to 1, otherwise it will be less than equal to 1. Try to keep in mind. Now what is diffuse surface? So radiating property not a function of direction. Direction is basically diffuse. So the property which is independent from the direction is known as diffuse surface. The property which is totally independent from the direction is not going to depend on any direction. This will be called is what? Diffuse surface. And what is gray surface? So radiative property independent from the wavelength. This is known as what? We can say gray surface. Now see here. Now I am going to discuss the concept of black body. What do you mean by black body? In the offline class I used to see when I ask the student what is black body, they think, sir, anything which looks like black in the color will be considered as black body. No, my dear friends, that is not a black body. Basically 2 or 3 important points that you have to be keep in mind about the black body. First point, they will absorb all the incident radiation. They can absorb all the incident radiation. Doesn't matter what is their wavelength, what is their temperature, nothing means is there. Whatever incident radiation is there, it can absorb all incident radiation. It can absorb all incident radiation. That is the first thing. Second thing, at any given temperature, emissive power of black body is maximum. That means at any given temperature, you know, this is the temperature of the surface, right? So obviously there will be emissive, their energy will emit, and obviously it is proportional to temperature, right? So at any temperature, maximum emissive power is for black body. That at any given temperature, the maximum emissive power you can get in case of black body. And one more thing, my dear friends, it is diffuse emitter. That emit can take place in all the direction. That's why it is called is what? Diffuse emitter. That's 2 points you have to be keep in mind. Right, black body, incident radiation, they will absorb all the black body. If you talk about radiation, black body depends upon the temperature as well as wavelength, but independent of direction. So that is the what? Black body. So a black body don't consider from their color. All which body which absorb all the incident radiation, nothing is going to be reflected, or at a given temperature wavelength, it can emit the maximum radiation. That is called is what? Black body. And yes, it is a diffuse emitter. That emit it not depends upon the direction. That's why it is called black body is called is what? Diffuse emitter. Now the question is that, sir, any body is black body. You might have listened the name of black hole, right? Black hole, you might have listened the name of black hole. So what black hole? Do you know about that? So what is the black body? Sir, is there any black body is possible, or it is a hypothetical? Yes, my dear friends, I can make a black body by just by 2 things. First, this is the one of the surface. Make it as a black, paint it as a black. You are going to paint it by a black color. A thick paint you are going to make here from the black color. This is a thick paint from the black color. Then it can be considered as a black body. Secondly, you can say, sir, suppose I have this is the one of the surface, right, and there is a small hole, from which incident radiation is coming. Now as it will come there, it will strike here, it will be some absorbed and some will be reflected back, again it will go there, again here it will be some absorbed and reflected back, again it will go there, here again it will be some absorbed and reflected back, again that will takes place several times or multiple times. This phenomena will happen, and ultimately all the incident radiation will be absorbed by that one. So this is very close to the black body. Now you might have listened the name of ice, right? Ice. So student usually confuse, sir, how ice can be black body. Ice can be treated as an black body. Why? Because yes, most of the incident radiation they are going to be absorbed, only few part which is going to reflected back, especially in case of infrared rays, they are not going to reflect anything. So ice can be treated as an what? Black body. So try to keep in mind all that point about the black body. And actually black body is a hypothetical body. If you think about it, is a hypothetical, but some body can be treated as an black body like ice, and that one, because once the radiation will come, it totally will be absorbed by different various times of reflection and absorb, various types reflected, absorb, reflected, absorb. So ultimately totally will be the absorbed. So they will absorb all the incident radiation. Now one of the very important things, my dear friends, we can say the VVI, very important, and this is what view factor. What is view factor? This is also known as shape factor, configuration factor or angle factor. So this view factor is very important, going to ask question from in every exams. So it is a purely geometric quantity and it is independent of the surface temperature. So what is view factor, sir? So view factor from surface I to j is the fraction of radiation leaving the surface I which strike on surface j directly. So what is this? As you know, sir, suppose that is the one of the body, right? That is the one of the body, that is another body. So from that I know radiation is emitted by everyone. So right, so see that some part will be gone and right now some will be go in this direction, some will go in this direction, like that, like na, this is. So they are going to emit the radiation in all the direction, right? So that is one, that is two. So they are going to emit that is total radiation, but how many fraction of that radiation which is leaving surface 1 going to the surface 2? So only that part, sir, only that part is going to 2 na. So this is called is what? View factor. So view factor is basically energy leaving the surface 1 and going to the surface 2. This is give the view factor. That totally depends upon the geometry. That's why it is called geometric quantity, because if I am going to change that body like that, then it will be change out, it will be change out, some will go more, right now. If I will make the small body, so some energy will, less energy will go. That's why it is called totally what, my dear friends? Shape factor or configuration or angle factor. It is a purely geometric quantity. They don't have to do anything with the what, my dear friends? With the surface temperature. So as temperature increases, it will emit in all the direction. Maximum temperature, as temperature increases, so radiation emitted in the all direction in the same proportion. Suppose whatever 50 temperature is there, so whatever emitted, whatever fraction is going to there, if I increase their temperature to 80, yes, now the emissive power will be higher, but the fraction will go here will be the same as it was earlier. So it is independent from the what we can say temperature of the body. Now, so what I can write, what is the that energy? I can say F of 1 2, energy radiation. This is what? F of 1 2. This is the fraction of energy which is leaving the surface 1 going to strike on the surface 2 directly. This is called is what, my dear friends? View factor. Now here some important thing that you have to be keep in mind. If you talk about view factor, one thing, first rule is called is what, my dear friends? Summation rule. Try to be keep in mind A1 F of 1 2. Okay, before that I am coming to the summation rule, then I will come on that. First I am going to discuss the summation rule. What is summation rule? Summation rule. What is summation rule? Suppose there are three surfaces. Let's assume this is surface 1, that is surface 2, that is surface 3. It is pointed from the outer surface. So whatever is happening, that is happening in the internal surface. Now tell me, whatever energy going to the surface 1, so we can say, sir, F11 plus F12, that is the energy leaving the surface 1, strike on the surface 1. That is the energy leaving from the surface 1, strike on the surface 2. That is the energy. Now that is the energy F13, energy leaving the surface 1 going to strike on the 3, that will be equal to 1. Similarly we can say, sir, for second surface F21 plus F22 plus F23 is equal to 1. That means whatever energy going to be emitted from the surface 2, it will either go to 1, either go to 3, or it will come on itself, right? I will see later on what will be F22. Here if we talk about F11 will be 0, F22 will be 0. Okay, how it is, I am coming on that one. Similarly for the third surface F31, F32 plus F33 is equal to how much, dear friends? 1. So by this you can solve the question. That is called simply what, my dear friends? Summation rule. And obviously you know whatever energy is going to be leave from the surface 1, either it will go on the surface 1 or 2 or 3, and if I add all the, that will be equal to 100% is equal to what, my dear friends? 1 you are going to be get here. Now see, next rule is what? Reciprocity rule. What is reciprocity rule? Reciprocity rule. reciprocity rule. What is reciprocity rule? This is, suppose that surface 1, that is the surface 2, so it will be f a1 f of 1 2 is equal to a2 f of 2 1. Try to be keep in mind, a1 f of 1 2 is equal to what, my dear friends? a2 f of 2 1. So that energy and their area, and the coming from that is going 1 to 2, and obviously it will come from 2 to 1 also, right now. So a1 f of 1 2 is equal to what? a2 f of 2 1. Try to keep in mind that relation will be used. Now I will discuss view factor, some special case. View factor in some special case. So my dear friends, suppose one of the flat surface is there, right? That is the flat surface. So if I will ask what will be the emissive power in that one, so what we can say? Let's assume anything is there. Suppose I have, let's assume my mobile phone is there. My mobile phone is there. From this, energy is also going to emit, right? So whatever energy is going to emit, it will not come on itself. So we can say in such case f11 will be equal to 0, sir. This is surface 1, this is our mobile phone. Whatever going to be, it will not coming on 1 itself. Whatever energy is going to be emitted, it is going to be like that. It is not coming on the surface 1. So here f11 will be 0. In case of flat plate, f11 will be 0. Now suppose this is our surface, right, which is painted from internal part, and whatever is happening from the external one. So here we can see, here also, sir, this is surface 1. So here energy is emitted like that, right? It is going to emitted like that. So here f11 will be also 0. Now just think about that. Now it is painted from the outer side. So is it possible now? Here some of the fraction of energy going to going that, some can go like that, some can go like that, some can come like that, right, like that. So some of the energy, that is surface 1, let's assume. So some of the energy which is going out from the one coming on itself. So it will be here, you can say in such case f11 cannot be equal to 0. By using these three rule, I can be able to solve all the different types of question which can be asked on the view factor. So now view factor basically energy leaving the surface 1 going to the surface 2 directly. Here that will f11, it will not come on that one. Suppose I will talk what will be f11 in that. What will be? Thing is happening externally, internally it is painted. So we can say, sir, here f1 is 0. Here f11 is what? 0. This is your cylinder, right? This is your cylinder, LPG cylinder, you can assume, and I am going to paint it from internal part. So what will be f11? That part painted from the internal. I am seeing from the external one, right? So what will be f11 here? You can say, sir, here f11 is also 0. Why? In the cylinder, just assume energy is going to be out, nothing is coming on that itself. So here it will be 0. Right now, so now let's start discussion with a few questions. Next, the process of heat transfer from a hot body to cold body in a straight line without affecting the interviewing medium. There is no any effect of interviewing medium. So what can be that mode of heat transfer, my dear friends? What can be that mode of heat transfer? Tell me. Yes, we can say, sir, there is no role of medium, then obviously that can be possible with the only radiation. So this is the answer you have, right? According to Stephen Boltzmann law, the relation between the total emission from a black body per unit area of that unit and absolute temperature T is given by. According to Stephen Boltzmann law, what was the Stephen Boltzmann law, my dear friends? What was the Stephen Boltzmann law? So it talk about the emissive power now. So what is emissive power? So we can say simply, sir, just now you have seen emissive power is equal to sigma into T k power 4. Here sigma is known as Boltzmann constant, right? Here sigma is known as what? Boltzmann constant. What is the value of Boltzmann constant? Anybody can tell me? Try to be remember their value. So here it is proportional to T k power 4. EB means basically for the black body, so that way we will get the answer. Sigma T k power 4. So here we can say emissive power is proportional to that one. Try to be keep in mind 5.76 10 to the power minus 8 watt meter square k k power 4. That question is also going to ask what is the unit of Stefan Boltzmann constant. So try to keep in mind. In these exam that type of question is going to ask. Ice is very close to what? Ice can be considered grey body, black body, white body or specular body. What is ice? So ice is what, my dear friends? Close to what? We can say black body. Ice is what? This is close to what? Black body. Next question. The wavelength of radiation emitted by body depends upon the surface, temperature, area, roughness or nature. So wavelength of radiation emitted depends upon the temperature, right? So what is the wavelength of the radiation which is emitted from the surface? That depends upon the what is the temperature of that surface, right? So basically that depends upon the temperature of the surface. So what we can say the answer? Here we can try to keep in mind that means displacement law. From the Lewis displacement law, lambda and T is equal to what, my dear friends? Constant. Lambda m and T equal to constant. That question is also going to ask in the gate various times in different PSUs. Simply they will ask what is the Lewis displacement law. Sometimes they are going to do the lambda and T1 and lambda 2 is given. They will ask what will be the T2 temperature. Such type of question is going to be asked. So lambda mean the wavelength which maximum emission takes place at absolute given temperature. Next question. A radiation shield should have high. What should be radiation shield? What is the radiation shield? If you have to reduce the radiation rate of heat transfer, then you are going to use the radiation shield. By using the radiation shield, radiation heat transfer is what, my dear friends? Decreases, right? So it depends upon what? Simply we can say, so it depends upon to reduce the heat transfer radiation between the surface by effectively increasing the surface resistance without actually removing any heat from the overall system. Radiation shield is used. Radiation shield have high reflectivity and low absorptivity. Try to be keep in mind that is the property of the radiation shield, should have high reflectivity and low absorptivity. Next question. A body which perfectly absorb and partially reflect but does not allow any radiation to pass through is called. A body perfectly partially absorb and partially reflect, okay, but it does not allow to radiation pass through, then which type of body it is called? A specular body, grey body, opaque body, or we can say none of these. What body? Which is just going to be allowed, they are not allow any radiation. So that type of body is known as what, my dear friends? What? Opaque body, right? So see, a body partially absorb or partially reflect but does not allow any radiation to pass through it, it is called opaque body. And you know, especially if you talk about radiation, so radiation is a volumetric phenomena. Radiation is what? This is a volumetric phenomena. But if you talk about in case of opaque body, since nothing is going to through that, so it will call it what? Surface phenomena. So try to keep that point in your mind that radiation is basically volumetric phenomena, but in case of opaque surface, radiation becomes surface phenomena. Here tau is 0 na for opaque body. For black body, alpha is equal to 1 because it is going to be absorb all the incident radiation. For white body, rho is equal to 1, alpha and tau is 0, where rho is reflectivity, alpha absorptivity and tau is what? Transmissivity. So that was the very simple things you have to be keep in mind. Opaque body, nothing is going to be, tau is 0, that means nothing is going to be, it can't be transparent. Black body, it will absorb all the incident radiation. White body going to reflect all that. Now, what is the disadvantage of using solar energy for production? Energy available in a daytime only. Initial cost is high. Requirement of large area for harnessing solar energy. All of the above. What is the disadvantage of using the solar energy? Anybody can tell me? Energy available in daytime only. Yes, solar energy only available in the daytime. So that one is right. Initial cost is high. Yes, that one is also right, because initial cost is very high in case of solar energy. Requirement of large area, obviously large area is needed. So we can say all of the above. D is the right answer. All of the above is the correct answer. So try to keep in mind that one. Right now. Next question. Okay, this is the disadvantage that you have to keep in mind. Next question. The shape factor of a hemispherical body placed on a flat surface with respect to itself. Shape factor means they are going to ask to calculate the view factor for a hemispherical body placed on a flat surface with respect to itself. Suppose that is the flat surface on which you are going to place a hemispherical body. So that is the hemispherical body, right? A shape factor for a hemispherical body placed on a flat surface, that is the flat surface, okay, with respect to itself. So let's assume if this is 1 or 2, whatever, let's assume 1, this is 2. So we can say in this question what you have to calculate, you have to calculate F11. What will be F11 in the question? So simply what you can use, this is the enclosure forms, the forms enclosure now. So can you write F11 plus F12 is equal to 1. Similarly, you can write F22 plus F21 is equal to 1. Yes, but if you talk 2 is a flat surface, from clearly flat surface is there. So we can say sir F22 is 0, right? So F22 is 0. So from there can I say F21 is equal to 1, and even you can imagine itself. Whatever energy that is a flat, and from that now, so whatever energy is going to release or radiated by that flat surface, totally going to the that one hemispherical part, right? So okay, now one more thing my dear friends, here you can say sir, if anyhow I know the f of 12, easily I can calculate the f of 11, and the question I have to calculate f of 11. So how you can do that my dear friends? From there how we can move? So we can say sir F11 plus F12 is equal to 1, and I know F21 is equal to 1. Now use the reciprocity rule. A1 f of 12 is equal to what? A2 f of 21. Can you use that one? Yes sir. So after that what you have to be do? See there, that is the 2, that one is the 1, hemispherical part is 1 and that one is 2. So F22 is what? That is the 0, right? Surface is 0. So surface 2 is flat. So we can say F21 is equal to 1, A1 f of 12 equal to A2 f of 21 from the reciprocity rule. So here what will be f of 12? So A2 plus into f of 21. So simply we can say na here from there. What we can say, tell me? So from here we can say, sir, I need what? I need f of 12. What will be f of 12? Can I write A2 upon A1 f of 21. What is f of 21? That is 1. So what is A2? So 2 is what my dear friends? What is A2? So 2 is simply we can say sir that hemispherical. So total is 4 pi squared. So what will be F12? We can say sir A2 is what? 4 pi r squared. Since hemispherical, so 2 pi r squared upon what? Pi r. Simply do one thing, make it correct. A2. So what is 2 my dear friends? 2 was that na? What is 2? So 2 is, sir, 2 is our flat surface na? 2 is our flat surface is here. So 2 is flat surface. So what will be? Pi r squared upon 2 pi r squared because of hemispherical. So f of 12 is coming to be 0.5. So what will be F11? F11 plus f of 12 is equal to 1 and f of 12 is 0.5. So simply we can get F11 is equal to what? 0.5. So what answer you are going to be get? 0.5. What answer? 0.5. C is the right answer. And in fact we can know the energy which is coming from there, it will be go to that surface, no problem, but energy from that you go like that, right now someone is coming, someone like that. So here we can say 50% is going to the itself only. Whatever energy you going to imitate, their 50% will go to the their surface itself. So that is the next question, my dear friends, on the screen. What is this? The question is that consider two infinitely long black body concentric cylinder with a diameter ratio d2 upon d1 is 3. The shape factor for the outer cylinder with itself. So you have a two infinitely long black body concentric cylinder. That means you have two concentric cylinder and their diameter ratio is known, my dear friends. So how you can do that? Tell me. How you can do that? So two cylinder is there now. Yes. So this is one of the cylinder. Long, infinite long concentric cylinder is there. That is the another cylinder. Right now, or that is long eccentric. That is insulated from the outer surface. And that one is insulated from the inner surface. That is insulated from the inner surface. Whatever is happening with the outer surface only. Here we can say d2 upon d1 ratio. d2 upon d1 is given 3 d2. So outer surface is considered as 2 and inner is considered as 1 according to given question. Now the shape factor for the outer cylinder with itself. The question is going to ask what will be F22. That question is going to ask what can be F22. That is the question is going to be asked. Right. If the question is going to ask what will be F11, so we can say, sir, this cylinder na, so everything is going to be releasing from, nothing is coming here. So F11 will be 0. Now use the summation rule. So we can say F12 plus F11 is equal to 1. Similarly for second surface, F21 plus F22 is equal to 1. We can say, sir, if you talk about F11, then this is 0, right? So from there f of 12 is equal to 1. You have to calculate F22. What can be F22? F22 will be, my dear friends, 1 minus f of 21. Can you calculate f of 21? Yes, sir, by using the rule of reciprocity. What is the reciprocity rule? Sir, A1 f of 12 is equal to A2 f of 21. I have to calculate f of 21. So I can say A1 f of 12 upon A2 is equal to what? F of 21. Right now. Yes, sir. Sir, f of 12 from the very question I have now f of 12 here is 1, f of 12 is 1. So f of 21 is equal to A1 upon A2. Now which area? Here you see the radiation is takes place in which area, my dear friends? Which area? So we can say in that area, na sir? In that area, na sir? In that area it is going to be takes place in that area, na? So this is what? Surface area, na? What this is? Surface area. So can I write surface area? So what we can say? Sir, F21 is pi d1 L1 upon pi d2 L2, or you can say L1 L2 is same, na? L1 L2 is same, pi. So ultimate d1 upon d2. Simply we can say, sir, 1 upon 3. So 1 upon 3 is what? 0.33. What? 0.33. So 1 upon 3 itself, B is the right answer. That way a question is going to ask from the view factor, and hopefully not you will find lot of difficulty solving that type of question. Easily we can proceed right now. Just keep we can say what the thing is going to be asked. F22 na, just 1 second, my dear friends. Here F22 I have to ask, not F21. Don't make a mistake. F22 I have to be calculate. So what will be F22? So it will be 1 minus f of 21. So what will be 1 minus 1 upon 3? So I will get 2 upon 3. The correct answer will be 2 upon 3, not 1 upon 3. Sorry for the make it correct. That not the going to be asked. The correct answer will be C for Chennai, because you have to calculate F22, not f of 12. Right now, so don't make a mistake like that. Yes, that thing a mistake going to made by the student also. So don't make a mistake like that, right? Yes, thermal equilibrium, the absorbability and emissivity are equal. This is equal, this is the Kirchhoff's law. At thermal equilibrium, this will be equal. That is the Kirchhoff's law simply. Stefan Boltzmann is expressed as, what will be Stefan Boltzmann law? how you are going to be define the Stefan Boltzmann law, my dear friends? Anybody? So we can say so sigma t ke power 4, that is the Stefan Boltzmann law. Sigma t ke power 4 is what? Stefan Boltzmann law. Now according to Stefan Boltzmann law, emissive power of black body is directly proportional to 4th power of absolute temperature. Try to be keep in mind that data 10 to the power minus 8 watt per meter square Kelvin. Heat transfer by radiation is less encountered in. Heat transfer by radiation is least when? So obviously when you are going to be insulated steam pipe, then you are going to be use that one. Okay, insulated steam pipe, then you are going to be use that one, right? So this is what radiation heat encountered will be in that case when it will be insulated. By which process solar energy converted into chemical energy? Yes, my dear friends, that question has been asked. So what is the process? You might have listened the name of photosynthesis na. So photosynthesis process, what is happening? Solar energy converted into the chemical energy. The correct answer is what? C4 Chennai. C4 Chennai is the correct answer. So for an opaque surface, what surface, my dear friends? Opaque. Opaque means tau is equal to 0. Transmissivity, reflectivity and rho are y. So we can say tau plus alpha plus rho is equal to 1. But sir, here tau is equal to 0. So alpha plus rho is equal to what, sir? 1. So for opaque surface, alpha plus rho is equal to what, my dear friends? 1. So we can say the correct answer is what? Chennai is the right answer. Try to be keep in mind, transmittivity in case of opaque surface will be 0. Nothing is going to be transparent there, right? Glass you might have seen transparent, that's why you are going to see one side to another side. Now that is the question, my dear friends. That is the next question. Hopefully you can be able to solve that question. Same question you have did. So that question I am going to give as a segment and you have to be answered that question. Okay, you have to be answered that question. Take it as a assignment, and yes, you can do, my dear friends. I don't think you will find difficulties. That is the another same question. So try to solve these two type of question and revert back. So my dear friends, you might have seen which type of question is going to ask in that, and be ready for that, and rest we will see. In the next session we will meet, we will see the different types of question and different subject. And yes, my dear friends, yes, if you are mechanical, obviously you have lot of opportunity in different PSUs. A lot of PSUs come. Yes, that is from the gate also, but from the non-gate also, because now you can see the recent trend. Most of the PSUs are going to take their separately exams. So yeah, I think it is a good also, because once your gate exam is going to be bad, then your whole year is going to be wasted. But now you have one golden opportunity, because most of the PSU is going to take their separate exams, and the question level is not much more difficult. So start your preparation, and hopefully you will be select. You can get select in any PSU, whatever you want. So start your preparation now, and as now Yourpedia. And yes, for those students, my dear friends, which is getting better marks in GATE, so you need post guidance after GATE. Obviously you need post guidance program. So as you know, Yourpedia is the leader in that field, so you can join us for your anything for PSUs or higher strategy, whatever. So you can join with us. Okay, so my dear friends, thank you. We'll meet in the next session with some other subject, some other concept. Thank you.